What specific problem does LongRAG aim to solve in the context of long context question answering, LCQA?
LongRAG aims to solve the lost-in-the-middle issue encountered by long context language models, LLMs, during long context question answering, LCQA, where relevant information is often located in the middle of documents, leading to suboptimal or incorrect responses. It addresses two major limitations of vanilla retrieval-augmented generation, RAG: the disruption of contextual structure due to chunking, which can result in incomplete information retrieval, and the low evidence density in long context documents that impairs the identification of key factual details. LongRAG introduces a dual perspective approach with components like a hybrid retriever and a COT-guided filter to enhance the extraction of global information and factual details, thereby improving the understanding of complex long contexts. By refining the contextual structure and increasing evidence density, LongRAG significantly enhances the accuracy of answers generated from long documents. Overall, it provides a more robust framework for effectively mining and utilizing long context information in LCQA tasks.
How does the proposed LongRAG algorithm work? Illustrate step by step the roles of the hybrid retriever, LLM-augmented information extractor, COT-guided filter, and LLM-augmented generator in the process.
The LongRAG algorithm operates through a structured process involving four key components: the hybrid retriever, LLM-augmented information extractor, COT-guided filter, and LLM-augmented generator. 1. Hybrid retriever. It begins by receiving a question and retrieving the top K relevant chunks from a long context corpus. This involves segmenting the source paragraphs into manageable chunks, while ensuring semantic cohesion through a sliding window technique. 2. LLM-augmented information extractor. The retrieved chunks are then mapped back to their source paragraphs to recover global context. This extractor employs zero-shot in-context learning to derive global information, enriching the context with background knowledge and structural insights. 3. COT-guided filter. Following extraction, the COT-guided filter generates a chain of thought, COT, that provides global clues for answering the question. It assesses the relevance of each chunk based on the COT, filtering out irrelevant chunks and retaining those that contain crucial factual details. 4. LLM-augmented generator. Finally, the generator utilizes both the global information from the extractor and the filtered factual details to produce a coherent answer to the question. This multi-perspective approach ensures that the generated response is accurate and contextually rich, effectively addressing the complexities of long context question answering.
Can you provide a detailed and illustrative example showcasing the inner workings of LongRAG, including how it retrieves and processes information from a long document?
LongRAG operates through a structured process that enhances the retrieval and processing of information from long documents. For instance, when a question is posed, the hybrid retriever first segments the long document into manageable chunks, while ensuring semantic cohesion through a sliding window technique. It retrieves the top K relevant chunks based on the question. These chunks are then fed into the long context extractor, which maps them back to their source paragraphs to extract global information, I_G, and maintain contextual integrity. Simultaneously, the COT-guided filter evaluates the relevance of these chunks, generating a chain of thought, COT, that guides the filtering process to identify factual details, I_D. Finally, the LLM-augmented generator synthesizes the refined global information and factual details to produce a coherent and accurate answer to the question, effectively addressing the challenges posed by long context question answering.
What are the theoretical or practical benefits of using LongRAG compared to existing RAG methods and long context LLMs?
The LongRAG system offers significant theoretical and practical benefits over existing RAG methods and long-context LLMs. Firstly, it effectively addresses the lost-in-the-middle issue prevalent in long-context LLMs by employing a hybrid retriever and a COT-guided filter, which enhances the identification of factual details and global information, leading to more accurate answers. Secondly, LongRAG surpasses advanced RAG methods, such as self-RAG and CRAG, by mitigating the noise and redundancy in retrieved chunks, thus improving evidence density and the overall quality of responses. Additionally, the automated fine-tuning data construction pipeline allows for efficient adaptation to various domains, enhancing the system's transferability and robustness. Empirical results demonstrate that LongRAG outperforms both long-context LLMs and advanced RAG methods by significant margins, confirming its superiority in handling complex long-context question-answering tasks.
How was the effectiveness of LongRAG validated? What datasets and evaluation metrics were used in the experiments to demonstrate its capabilities?
The effectiveness of LongRAG was validated through extensive performance comparisons and quantitative ablation studies conducted on 3 challenging multi-hop datasets, HotPot QA, 2Wiki Multi-Hop QA, and Musique, which were selected from LongBench. The evaluation metrics used to demonstrate its capabilities included the F1 score, which was reported for all 3 datasets. LongRAG significantly outperformed both long-context LLMs and advanced RAG methods, achieving improvements of up to 6.94% over long-context LLMs and 6.16% over advanced RAG methods, as well as a notable 17.25% improvement over vanilla RAG. These results confirm LongRAG's superior ability to handle complex, long-context question-answering tasks effectively. The experiments also highlighted the robustness and transferability of LongRAG across different fine-tuned LLMs.
What limitations or constraints does LongRAG face, and how might they impact its applicability in real-world scenarios?
LongRAG faces several limitations that could impact its applicability in real-world scenarios. Firstly, while it employs a hybrid retriever and a COT-guided filter to enhance the retrieval of relevant information, the reliance on these components may still lead to challenges in accurately identifying factual details, especially when relevant information is dispersed across multiple chunks. Additionally, the system's performance can be affected by the quality of the input data. If the long-context documents contain considerable noise or low evidence density, it may hinder the effectiveness of the retrieval process. Furthermore, the automated fine-tuning data construction pipeline, while efficient, may not always guarantee high-quality instruction data across diverse domains, potentially limiting the system's transferability. Lastly, the performance gains observed in controlled experimental settings may not fully translate to more complex, unpredictable real-world environments where context and user queries can vary significantly.